Welcome to Ask and Learn.
Hello friends, here it is given a wheel of radius r. This is a wheel of radius r rolls without slipping along the inside of the fixed cylinder of radius capital R with constant angular velocity omega. So angular velocity of the wheel is given omega. Denoting by P point on the wheel in contact with the cylinder at t is equal to 0. So P point is here at t is equal to 0. Position of point P. We have to find the horizontal and vertical component of velocity of P point. Find horizontal and vertical component of velocity of P point. We have here drawn the geometry. After t second, P point reaches from here to here with angular displacement theta. And angular velocity of the wheel is defined as d theta upon dt, or you may call theta dot. Here theta is equal to, you may write omega into t. Since the wheel rolls without slipping, since wheel rolls without slipping, so the arc OC, this is O, I'm marking in the figure. This is O and this is C. So arc OC is equal to PC. So we can write R plus theta plus phi to be equal to R into phi. So value of phi will be R theta upon R minus R. Now differentiate with respect to theta, so you will get phi dot R upon R minus R d theta upon dt theta dot, so you may write phi dot to be R minus R omega. Now value of xp can be written as, x coordinate of P point can be written as R minus R sin of phi minus R sin theta. You have to purely use the geometry. So velocity of P point along x-axis will be dx upon dt, that is R minus R cos of phi d phi upon dt minus R cos of theta d theta upon dt. Phi naught we know, this is omega. Substitute the value. So R minus R cos of phi d phi upon dt is R upon r minus r into omega minus r cos theta d theta upon dt is omega. So on solving it, you will get the velocity of P point along x-axis. So velocity of P point along x-axis is r omega. Common you can take cos of just a moment please. If you take r omega common to the both side, you will get this will cancel out. Phi you can substitute from here. So phi is r theta over r minus r minus cos of theta, and theta can be written as omega t. So velocity of P point, you may write r omega cos of r omega t upon r minus r minus cos of omega t. So this is the velocity of P point along x-axis. Now we have to find the velocity of P point along y-axis. So we will find the y-coordinate of a P point. So by P can be written as r minus r cos of phi minus r cos theta. Differentiate with respect to t. The velocity of P point along y-axis d by p upon dt, r differentiation 0, cos of phi minus sin of phi into d phi upon dt, that is phi dot r plus positive sin of theta dot. This is omega and phi naught we know. So r minus r sin of phi phi naught, and this is r sin theta into omega. Now phi and phi naught you may substitute here. So finally you may write the velocity of P point along y-axis. We can write like this. Remember it, we are substituting the value here, r minus r sin of phi. Phi is r theta upon r minus r, phi not having the value r omega t over r minus r theta into omega. This will cancel out. R omega you can take outside. Just a moment. R omega you can take common. So finally you will write sin of r omega t over r minus r plus sin of omega t. So this is the velocity of the P point along y-axis. That's all for this problem. Thanks for